Hey guys, today I'm going to discuss to you some word problems about direct variation with easy as its level of difficulty. So problem number 1. The weight of an object on Earth varies directly as the weight of the same object on the Moon. A 300-pound object would weigh 48 pounds on the Moon. How much would a 65-pound object weigh on the Moon? So we have here the step 1. The formula is y is equal to k times x, denoted by E as for the Earth, equal to k as the constant of variation, and m is for the Moon. These are the given. E is equal to 300 and m is equal to 48. Now we have to solve for k first. And for our step 2, we have here the formula E is equal to k times m. The E there is 300 equal to k times 48, which is the value of m. To solve for k, we have to divide both sides by 48 to isolate the k there. So we have this explanation: reduce your answer to lowest term, and we have here the value of k, which is 25/4. Now again, 25/4 is our value of k. Next is we have to solve for m by using the formula and substituting the value of k and e. So we have the solution. The step 3, e is equal to 25/4, which is the value of k, times m. And in step 4, substitute the value of e, which is 65 pounds. So we have the 65 equal to 25/4 times m. In step 4, solving for m, we have to multiply both sides by 4. So we have here, and on the right side, as you can see, number 4 in the numerator and in the denominator becomes 1. So you're going to cancel it out. So from there, we have here now on the left side, we have the 4 times 65 equals to 25m, and 4 times 65 is 260 equals to 25m. And solve for m by dividing both sides of the equation by 25. So we have here our final answer. We have m is equal to 52/5, or equal to 10.4 pounds. And in our solution, we have the value of m, which is 52/5, or 10.4 pounds. So again, in problem number 1, the weight of an object on Earth, E, varies directly as the weight of the same object on the Moon, m. A 300-pound object would weigh 48 pounds on the Moon. How much would a 65-pound object weigh on the Moon? So the formula is y is equal to kx, denoted by E is equal to km. The given are E is equal to 300, m is equal to 48. Substitute the given to the formula. We have 30 equal to k times 48. To solve for k, simply divide both sides of the equation by 48. So we have here the final answer, which is in lowest term. We have the value of k equal to 25/4. Now in step 3, we have to solve for m, and by using the formula E is equal to k times m, and we all know that the value of k is 25/4. And after having 25/4, substitute the value of e, the second value of e, which is 65. So in step 4, as you can see, we have the 65 equal to 25/4 m. And then we have to divide both sides of the equation by 4 to eliminate the 4 in the denominator. So what remains is we have to multiply 4 times 65 equal to 25m. And we have here our final answer. The value of m is equal to 52/5, or equal to 10/10.4 pounds. Problem number 2. The distance required to stop a car varies directly as the square of its speed. If 250 feet are required to stop a car traveling 60 miles per hour, how many feet are required to stop a car traveling 96 miles per hour? So we have again this formula, y is equal to k times x, and it is denoted now by d as for the distance equal to k times s squared. So we have squared here since the speed is being squared. in the problem. So for our explanation, we have denote D as the distance and S is for speed. Step 2. Since the speed is being squared, so that's why the formula becomes D is equal to K S squared. Step 3. Substitute the value of D, which is 250, and the speed, which is 60. So we have here the 250 equals to K times 60 squared. So as we all know that 60 squared is equal to 3,600. So 250 equals to 3,600 K. Solve for K by dividing both sides of the equation by 250, then reduce the answer to lowest term. So 250 over 360, 3,600 equal to 3,600K over 3,600. So we have the value of K, which is equal to 250 over 3,600, or in lowest term, K is equal to 5 over 72. So in our solution, we have here the value of K, which is 5 over 72. Step 6. Solve for D by substituting the value of K times the second value of the speed, which is 96. So D now is equal to 5 over 72, which is the K, times the 96 squared, the second value of the car, the speed of the car. So step 7, and 96 squared is equal to 9,216. Step 8, multiply 9,216 times 5, then divide it by 72 to get the answer of 640 feet. So you have there in the illustration. And for our solution again, we have D is equal to 9,215 times 5 over 72, and the D is equal to 640 feet. Going back to our second problem, the distance required to stop a car varies directly as the square of its speed. If 250 feet are required to stop a car traveling 60 miles per hour, how many feet are required to stop a car traveling 96 miles per hour? The formula is D is equal to K S squared. So substitute the given, we have the 250 equals to K times 60 squared. And 250 is equal to 3,600 K. Isolate K by dividing both sides of the equation by 3,600 to get the value of K, which is in lowest term, equal to 5 over 72. To solve for D, all you have to do is use again the formula. D is equal to K S squared. And in here, we're going to use the second value of the speed, which is 96. So D is equal to 5 over 72 times 96 squared. And D now is equal to, the 96 squared is 9,215 times 5 over 72 to get the final value of D, which is equal to 640 feet. And that's all for this presentation, guys. Hope to see you in my next video. Thank you for watching.